Hello everyone, here's JJ, and this video I will show two ways to prove the formula for cross product of vector. So let's go. The first way is using pure algebra way. So okay, assume we have two vector. This vector V. This vector U. And we know that this two vector can also write as this form. AI hat plus BJ hat plus CK hat, and same you can write as BI hat plus EJ hat plus hat A hat, right? So you know that we cross product U is equals to you get this, right? And remember, cross product also follows that rule like that. So vector U plus vector V, sum cross product with vector W is equals to U cross product W plus V cross product W, something like that, right? Or also like same as this. If we like use W cross product with U plus V, it's also the same. It's like W cross product with U plus W cross product with V. Why I have to write two times is guys because for cross product, normally A cross product B does not equal to B cross product A. So like that. But it's work for both sides. Therefore, you can use this rule to simplify something here. So we can get, after we expand it, we'll get 6 terms, right guys? So AI hat, DI hat, cross product with DI hat, AI, then BJ, DI, CK, DI, AI, EJ, BJ, EJ, CK, EJ, AI, FK, BJ, FK, CK, FK, like that. So yeah, 3 times 3, this should be 9 terms after we expand it. And right now we can calculate each term, because guys, the thing is, A, B, C, D, E, F, they are real number. They are real. So when we time them together, we can it's just like real how time works in real number. So we can just move all the coefficient in front of all the cross product. So right now we only have to focus on how cross product work between different dimensions unit vector. So okay, Remember, so it is a chart. So the arrow means it's like the thing here, cross product the thing here. It's first, it's second. So here is I cross product with I. So we know that a vector cross product of itself. You see, two vectors, they're exactly the same. So the parabola is formed. The area of parabola these two vectors form. You see, form. The area is 0. So the cross product of I is 0 vector. The same for J, 0 vector. KK is also 0 vector. And then let's do I cross product J. So we assume, yes, okay, see, we assume I had cross product J hat is K hat. So IJK is like, so when you show your right hand, so this finger should be I, this finger should be J, this finger should be K. Then we can see. So if I cross product J is K, then J cross product I should be negative K. And then let's see. It is I, it is J, it's K. So it's J, it's K, then it's I. So J cross product K is I. J cross product K is I. I had, yeah, true. So same. Then K cross product J should be negative I. Hat. Okay. And then the last one, let's see. IJK. So this is K, this is I, this is J. So K cross product I is equal to J. So K cross product I will be J hat. And then opposite, I had cross product K hat should be negative J hat. So according to this, we can simplify this thing here. So, okay, so we know that this term will disappear, this term will disappear, this term will disappear, and then let's continue to simplify. Ji is negative K hat. Ki is J hat. The Ij is K hat. Kj is negative I hat. Ik is negative J hat. Jk is I hat. So after we simplify, we can get is equals to negative BDK plus CDJ, then plus AEK plus CE minus CE I hat, the plus minus AF J hat, then plus BF I. And let's continue simplify. Then we will get first let's calculate I. It will be BF minus CE I the plus CD minus AF J plus AE minus BD K hat, like that. So yeah, that's it. That is the formula. I mean, for this, I use 6 different letters, but I mean, you can compare your formula booklet with just like maybe isn't A1, A2, A3, B1, B2, B3. You can replace all the letter with A1, A2, A3, B1, B2, B3, and check if this one is correct or not. So yeah, it's like using algebra way to prove cross product. So yes. So the thing is like we have to use the definition of like right hand rule to check the sign, the result of cross product of 2 unit vector, like that. So remember, I, J, K. So I cross product J is K, then IJ, then see, J cross product K, it will be I, and K cross product I will be J. So it's like that. So it's first way. Okay guys, I'm going to introduce a second way using the definition of cross product. So, okay, it is result vector. So the cross product of U and V, the result of cross product is a vector. So vector is perpendicular to both two vectors. So we can say that the dot product of U and this vector is equal to 0, and the cross product of dot product of V and U and the result vector is also 0. So according to the formula for dot product, we can get this two equation. So right now we can solve the system. And here's this. And guys, we can observe these two equations first. According to what we learned, these two equations represent two planes, and both two planes go through origin, and also so these two planes will cross with each other, and we'll get a line. The direction of the line is same as the direction of the cross product, the result vector. Yeah, so, and also the thing is, the line that these two planes form also goes to the original point. So let's solve this system, because we know that these two planes will form a line. So actually this line can write as that form. It's like AX plus PX plus QY equals to Z. This line can write as that form. Why? Because we know that this two plane will form, the line that this two plane form goes through the original point. So it means it's linear. It should be linear like that. So according to this, we assume the result is like that. So we can do z as a constant, and then we'll get a1x plus a2y is equals to negative a3z, and b1x plus b2y is equal to negative b3z, like that. Then we can solve it. Yes, quite complicated, but then you get the result. So you can solve it. So x is equals to a1b3 minus a3b1 over a1b2 minus a2b1 times z. The y is equal to this. So the way I solve it is using using linear algebra. So the equation system like that, like two unknown equation. You can use something similar to the magnitude, but this sign for matrix. So yeah, I will search the name of it. So I use this way to solve the equation, and we get x is equal to this times z, y is equal to this times z. So actually we get that form. Then we will get this form. Then we know that this vector lies on this line. And then, we still can simplify this equation to make it like more similar, change it to a similar structure, and we can observe it, and we see a1 b2 a2 b1 a1 b2 a2 b1. So we can divide it by a1 b2 minus a2 b1 for all the part of the equation. So we can get x over a2 b3 minus a3 b2 equals to y over a3 b1 minus a1 b3 equals to z over a1 b2 minus a2 b1. We can get this line equation, and actually if you observe this three stuff, you realize that this three is the thing actually we need for the cross product. But how can we prove it's like that? So guys, so we have to remember there's another restriction. So the length of the result vector is equal to the area of parabola this two vector form. So the area of the parabola this two vector form is equals to the length of this vector times the length of that vector times sine theta between these two vectors. And the thing is, later on we'll learn trigonometry, and actually we know that sine theta is equal to square root of 1 minus cosine square theta. So the area of the parabola can write as that, and we can time the u magnitude, this v magnitude inside the square root, but we have the squared, then we can get u magnitude squared times v magnitude squared minus u dot v squared. And then we can expand it. We will get a1 square plus a1 square plus a2 square plus a3 square time b1 square plus b2 square plus b3 square then minus a1 b1 a2 b2 a3 b3 square, then take square root of whole stuff. So let's simplify this. We can get, so we will get 9 term again. So this we will also get 9 term. So that's why we have to compare this. Okay, so let's simplify a1 square plus a2 square plus a3 square time b1 square plus b2 square plus b3 square. This we will get a1 b1 square plus plus a1 square b1 square a1 square b2 square plus a1 square a1 square b3 square plus a2 square b1 square a2 square b2 square a2 square b3 square plus a3 square b1 square a3 square b2 square a3 square b3 square, like that. We get 9 terms. And let's look at a1 b1 plus a2 b2 plus a3 b3 square. We will get, this one is much complicated, but we can check. So we will get a1 b1 whole thing square plus a2 b2 whole thing square plus a3 b3 whole thing square plus 2 a1 b1 a2 b2 plus 2 a2 b2 a3 b3 plus 2 a3 b3 times a1 b1. We can expand this because it is we can expand it by the formula a plus b squared is equal to a squared plus 2ab plus b squared, but it's 3 terms, so we have to expand it like more time. But after we open the square is like that, then we have to use this minus this, so we can compare them. a1 b1 square is a1 square times b1 square. We can cancel that out, and a2 b2 square is a2 square b2 square. a3 b3 square this a3 square b3 square. Then we have this thing minus this whole thing. And wait, before we continue, we can check as well. So this two will minus with each other, then we will get. Before that, I have to simplify this. So for all of the stuff, we have observed that it's like a something square times b something square. So we can simplify it as, for example, a1 square b2 square is equal to a1 b2 square. a1 square b3 square is a1 b3 square, and so on. a2 b1 square, a2 b3 square, a3 b1 square, a3 b2 square. And then look at this, there's 3. So look at this. So first I write a1 b2 square, then minus what? Minus minus 2 times a1 b1 a2 b2 plus a2 b1 square, then plus a2 b3 square minus 2 times a2 b2 a3 b3 plus a3 b2 square, and the last, wait, let's check. I already use this, this, we used a2 b3 square, a3 b2 square. So at the end we have a3 b1 square, and there we use a1 b1 a2 b2 a2 b2 a3 b3. We have minus 2 a3 b3 a1 b1, then plus a1 b3 square. It's the same inside of square root, and we still continue to simplify them. Guys, the thing is, look at here. It is a1 b2 square, it is a2 b1 square, and actually for the middle part we can directly break the bracket and then we will get a1 b1 a2 b2 a2 b2 a3 b3 a3 b3 a1 b1. We can arrange them to the form we need. Look at here. It's a1 b2, it is a2 b1. So the thing is, it was a1 b1 a2 b2, but we can write as a1 b2 a2 b1. For this is same. a2 b2 a3 b3 is a2 b3 a3 b2, and 3311 3113. Then we realize that it's we can use formula to simplify it as well. Then at the end, we can get the whole thing is equals to a1 b2 minus a2 b1 square plus a2 b3 minus a3 b2 square plus a3 b1 minus a1 b3 square. So according to the definition of cross product, like about the magnitude of the result vector, we get the length of the result vector should be square root of that thing. And let's compare square root of that thing. Let's compare the length of the magnitude of the result vector with the line, the direction line of the result vector, this. We realize that if x is equals to a2b3 minus a3b2, y is equals to a3b1 minus a1b3, z is equals to a1b2 minus a2b1. Let's check. So it's one solution, and the thing is, x squared plus y squared plus z squared, then take square root, is the length of a vector, right? It's exactly the same as this, the thing we need. So the thing, guys, this is the area of the parabola, the two vector form, and it's also equals to the length of the vector, like that. So actually, this is the exactly the result vector. So this is second way to get cross product formula by using the definition. So yeah, it's more complicated compared to the first one, because first one you only have to know the one property of cross product, but for this one you have to be more creative, because you have to solve 3 unknown with 2 equations. It's something you never learned before, so yeah, like that. Thank you for watching. This video is really complicated, so if you want to know how did we get cross product formula, then it will be a really interesting video. So that's it.